Hi everyone, today I'll be looking at invertible counterpoint. Although I'll be looking at 2, 3 and 4 part invertible counterpoint, for ease of discussion I'll only use examples of 2 part counterpoint, except when specifically referring to 3 and 4 part writing. Invertible counterpoint is counterpoint written so that each part may function as both the upper part, or parts, and as the lowest part of a texture, while still adhering to the rules of part writing and dissonant treatment. Of course, the rules of part writing and dissonant treatment only apply if you're writing in the style of the classical masters. If you're writing in a modern style, the rules are often only partially adhered to or are completely ignored. In 2-part textures, invertible counterpoint is typically called double counterpoint, as each part has a double function as the lower and upper part. In 3-part textures, invertible counterpoint is called triple counterpoint, and in 4-part textures it's called quadruple counterpoint. These terms only apply to counterpoint where each part can successfully be interchanged with the others. In other words, not all 2, 3 and 4-part counterpoint is invertible counterpoint. Invertible counterpoint is typically not used for an entire work, but is introduced either periodically or through a section or sections of a work. Typically it's the theme or subject which is written so that it may be inverted with itself or with another theme or counter-subject. In the case of the fugue, often subjects and counter-subjects are introduced separately before then being combined using invertible counterpoint. Invertible counterpoint is typically used at the following intervals: the octave, the 10th, and the 12th. In all of these instances, the inversion may occur at the given interval or at multiple octave distances of the given interval. There are 3 common ways in which invertible counterpoint occurs. One part may remain stationary while the other part moves the required interval. Both parts may move the required interval, or both parts may move at intervals which add up to the combined sum of the inversion chart for the particular counterpoint in use. This third type may be used to introduce a section of invertible counterpoint on different degrees of a key or in a new key. Before I discuss this process, however, let's look at what the inversion charts are. Discussion of invertible counterpoint typically includes inversion charts showing how each interval inverts. For invertible counterpoint at the octave, for example, the chart shows that the octave inverts to a unison, the 7th to a second, the 6th to a third, and so on. Perhaps this information can more clearly be seen in the following example, where again the octave inverts to a unison, the 7th to a second, and so on. Notice that with invertible counterpoint at the octave, most consonant intervals invert to consonant intervals, the octave to unison, the 6th to the third, and so on, while most dissonant intervals invert to dissonant intervals, such as the 7th to second. The only exception is the consonant 5th, which inverts to a dissonant 4th. Notice also that the combined sum of each vertical column equals 9 and not 8. 8 plus 1 equals 9, 2 plus 7 equals 9, etc. 9 therefore is the combined sum for invertible counterpoint at the octave. For invertible counterpoint at the 10th inverts to a unison, the 9th to a second, the octave to a third, and so on. With invertible counterpoint at the 10th, consonant intervals again remain consonant when inverted, and dissonant intervals remain dissonant. However, because the 10th, 3rd, and 6th now invert to the unison, octave, and 5th respectively, these intervals cannot be used together as they invert to a series of forbidden consecutives. For invertible counterpoint at the 10th, the combined sum of each vertical column equals 11, 10 plus 1 equals 11, 9 plus 2 equals 11, etc. 11 therefore is the combined sum for invertible counterpoint at the 10th. For invertible counterpoint at the 12th inverts to a unison, the 11th to a second, the 10th to a third, and so on. When inverted, consonant intervals again essentially remain consonant and dissonant intervals remain dissonant, although here the consonant sixth inverts to a dissonant seventh. The combined sum of each vertical column equals 13. 12 plus 1 equals 13. 11 plus 2 equals 13, etc. 13 therefore is the combined sum for invertible counterpoint at the 12th. Taken on its own, this information gives a guide to how each interval inverts. However, because some consonant intervals invert to dissonant intervals, and because in some contexts even consonant intervals can be dissonant, all resulting harmonic inversions must be considered for each combination of parts. For example, according to the inversion chart for invertible counterpoint at the octave, when a third inverts to a sixth, both intervals remain consonant and should therefore be usable in most situations. In the following example, however, this third inverts to a sixth, but in this context the sixth is dissonant as it produces a second inversion F major chord. When writing invertible tonal counterpoint, therefore, all harmonic inversions must be considered for each combination of parts, even when working with consonant intervals. The information in the inversion charts, therefore, should only be used as a guide, but is always superseded by harmonic considerations and the rules of part writing and dissonant treatment. As I mentioned earlier, not only can parts be moved at the distance of the invertible counterpoint you're using, either octave, tenth, or 12th, but they can also be moved at distances which together equal the combined sum for that type of counterpoint. For example, as we've seen, the combined sum for invertible counterpoint at the octave is 9. Using the inversion chart for this type of counterpoint, if we wish to move the following C major excerpt so that it outlines subdominant F major harmony rather than tonic harmony, we would first move the lower part up a fourth so that the C now begins on F, and then move the upper part down a fifth so that it begins on A, the third of subdominant harmony. Here, one part moves a fourth and the other part moves a fifth, which together equal 9, the combined sum for this type of counterpoint. We could also move the lower part up a sixth and the upper part down a third so that submediant harmony is produced. Here again the parts have moved distances which equal the combined sum for invertible counterpoint at the octave. For us to move this excerpt so that it outlines tonic harmony in the key of G major, again we would move the parts the requisite intervals. We would then need to sharpen the F so that the key is now G major. Of course, this type of transposition can be achieved using only a knowledge of harmony. For example, here where we moved from tonic to subdominant harmony in C major, the melodic contour of the lower part moves from the root note of the C major chord down a semitone before returning to C, while the top part begins on the third of C major harmony before descending stepwise to C. We can therefore simply transpose this information to F. The lower part is now the upper part, but still begins on the root note of the chord, in this case F, and moves down a semitone before returning to F, while the lower part again begins on the third of the chord before descending by step to the root note. The theme of invention number 6 in E major by J.S. Bach is an example of double counterpoint and consists of 2 E major scales moving in contrary motion. One part ascends by step through one octave of E major, while the other part descends by step, again through an octave of E major. The parts are initially presented for 4 bars with the ascent in the left hand and the descent in the right. They are then inverted an octave for the following 4 bars, with the upper part being lowered 2 octaves and the lower part raised an octave. Notice when the parts are inverted, root position chords typically become first inversion chords and vice versa, although the initial tonic remains in root position. Because the parts are staggered, suspensions are created, In this bar, a 7/6 suspension, and in this bar, 4/3, 2/1, and 7/6 suspensions. When inverted, the 7/6 suspensions invert to 2/3 suspensions, while in this context, the 4/3 and 2/1 suspensions invert to a series of rising intervals and no longer behave as suspensions. By bar 20, the invention has modulated to the dominant key of B major. To introduce the theme in the dominant key, Bach simply moves the descending part up a fifth and the ascending part up a fourth, distances which equal the combined sum for invertible counterpoint at the octave. Alternatively, Bach may have effected the modulation simply by transposing the theme so that it now begins on B and outlines a B major scale. Fugue 4 in C-sharp minor from Book 1 of Bach's Well-Tempered Clavier is an example of triple counterpoint. The triple counterpoint occurs between the real subject and two counter-subjects. As you can see, the subject and counter-subjects each have a distinct melodic contour. The subject outlines a stepwise descent from the third to the root note. The first counter-subject outlines a descent from the fifth to the third. And the second counter-subject moves from the root note to the seventh and back. Because the subject is real, it can be introduced with its accompanying counter-subjects in various keys simply by beginning on the relevant tonic note. Throughout the fugue, the subject and counter-subjects are first introduced separately before being combined. The subject is initially introduced on its own. The first counter-subject and subject are then combined. Before the second counter-subject is combined with the others. Although the subject and counter-subject are used in different keys and sometimes with slight rhythmic and/or intervallic alterations, they are always introduced with the same metric relationship, which produces the following progression in any key. Whenever the first counter-subject is in the lower part of these entries, a second inversion tonic is produced here on the third quarter note beat of this bar. Because of its context, however, here occurring between two dominant seventh chords, and because the melodic contour of the first counter-subject moves to the third of tonic harmony through a resolution of the seventh, the second inversion can be heard as a passing 6/4. Throughout this fugue, the invertible counterpoint occurs at the octave. Here in bars 38 to 41, for example, the subject is moved up a fifth and the first counter-subject down a fourth for an entry in G-sharp minor. Fugue 12 in F minor, again from Book 1 of Bach's Well-Tempered Clavier, is an example of quadruple counterpoint. The quadruple counterpoint occurs between the tonal subject and three counter-subjects, which are introduced sequentially during the fugue's exposition. As with the fugue in C-sharp minor, the subject and counter-subjects each have a distinct melodic contour. The subject outlines a descent from the fifth to the root note of F minor. The first counter-subject essentially moves from the root note to the seventh and back. The second counter-subject descends from the fifth to the third. And the third countersubject sustains the fifth after an initial ascent from the tonic. The subject and countersubjects are always introduced with the same metric relationship, although sometimes have slight rhythmic and/or intervallic alterations. The subject or countersubjects may also be shared across two parts of the texture. In bar 13, for example, countersubject 2 is initially found here before moving to the alto part. In this fugue, Bach only uses two of the many possible part combinations for the quadruple counterpoint. One combination begins in bar 13 and the other in bar 27. Both examples are in the tonic key of F minor, and in both examples the countersubjects occur in the same ascending order of 1, 3, and 2. The subject is used at the top of the texture in bars 13 to 15, and in the lowest part in bars 27 to 30. Throughout this fugue, invertible counterpoint again typically occurs at the octave, although beginning in bar 19, the subject is lowered a fourth and the first countersubject raised a ninth for an entry in C minor. The invertible counterpoint therefore here occurs at the 12th, as the combined sum of this inversion is 13. So far we've looked at examples of double, triple and quadruple counterpoint where the subjects and countersubjects each have their own distinct melodic contour which are combined using invertible counterpoint. Another way in which invertible counterpoint is utilized occurs when the different types of invertible counterpoint are used to generate multiple melodies from a single subject. The subject from Fugue 22 in B-flat minor, for example, in its original form essentially outlines an ascent from the root note of B-flat minor to the fifth before descending to the third. Because Bach treats it as a real subject, the same melodic contour is used for the answer in the dominant key of F minor. Another ascending form of the subject begins on the raised leading note of the key. It has the same melodic contour as the original subject but is displaced by a half note beat so that it begins on the second beat of the bar. The position of this subject can be heard as an example of invertible counterpoint at the 10th. Here in bar 27, the subject is moved up an octave from its last entry and the displaced subject begins a third below but is utilized above the original, thereby creating a sixth between C and A. Along with the original form of the subject, Bach also uses an original inverted form which descends from 5 to 1 before returning to 3. A displaced descending form is also used, which, like its ascending form, begins on the second half beat of the bar. It can also be heard as an example of invertible counterpoint at the 10th. Here in bar 67, for example, it begins a tenth above the E flat. 10 plus 1 equals 11, the combined sum for this type of invertible counterpoint. The various subject forms are combined throughout this fugue, although one subject form is only ever combined with another. That is until bar 96, where Bach combines the original subject form with three of the other forms. The original ascending subject is combined with another ascending subject at the 10th, which is here used below the original, creating parallel sixths. The displaced descending form, here beginning on G flat, is itself a tenth above the E flat note of the original descending form. Here it is combined with another displaced descending form, which begins a tenth below G flat, but is here written as a third. I hope you found this useful. Thanks for watching. See you next time.